Okay, everyone, thanks for coming. This is going to be an unusual presentation for us. We've never done one like this, in that we purposefully did not really talk too much about these topics before this webinar, because we wanted it to be more of a conversation where different ideas would show up and would appear, and we might, you know, contradict each other and tell each other we're wrong, and who knows, maybe we'll even get acrimonious at some point. All right, so myself, I think almost everybody knows, has heard of me or knows what I am or whatever. All three of us have been in the business for 20 to 30 years. I've probably been in the business the least amount of time, and I think Marco the most. So I'm from Abraxas. I'm the president. I've been doing M&B or associated with M&B for a long time. But Marco and Phil are a lot more involved in M&B than I am, and have been. Yes, they've done a lot more M&B than I am. That's all I can tell you. Marco is in charge of, I believe, the East Coast of Honeywell's M&B team, and has been for a long time. I've known Marco for maybe 20 to 25 years. One of my first memories of him was at a trade show at a World Energy conference, and he would just follow me around as I was going from booth to booth, and he would say, and I asked, why are you following me around? He says, because I like hearing you tell vendors why their products won't work, and because that's what I was doing. And anyway, we'll leave it at that. So Phil, I don't have that experience with, but Phil is always has super nice things to say to me, even after our worst webinars. He's always telling us how good they all are, which means that maybe you can't really trust what he says when he's praising you. But anyway, let's move on. So I do want to mention this. We're good at what we do, but look, all of us, including you on the webinar who aren't speaking, we're all figuring this out as we go, but you're going to hear from some people who've been around for a while and who have some interesting things to say. And I guess you trusted that that's what would be the case, and that's why you're here. Another thing is, these are personal opinions. These are not the official stance of Trane or Honeywell or of Abraxas. We're just throwing ideas around, and you will determine how you're going to handle things in the future. Okay. The topics we're going to look at today. First, we're going to look at some data. All three of us will show data for about 5, 7, 8 minutes each, what we've seen. And then we will talk about adjustments, non-routine adjustments or baseline modifications, same thing. And how we'll talk about it and whether they're appropriate or how they should be done, et cetera. Also, how does this COVID data affect these new projects? For example, if you're doing a new performance contract and your base year has COVID data in it, how are we going to handle that? And then also, if we have more time, we could talk about the good that actually can come of this, that you could actually use this as a learning experience. So those are our topics. I didn't want that slide yet. So we are open to questions, as this is more of a discussion than us just throwing a monologue at you. Please ask questions as things come up, and we'll be looking at them from time to time and answering them. I think your questions will make it a better webinar. Okay, so the first thing is data. I want to show you some of mine, and I believe this would be the first one. So this is a project, a school district project that a friend of mine gave me, and his data is really interesting. So this is an option C project, obviously, and he had school day data. So he's got number of school days per month, and they were open for 5 days in March, and after that, they closed. And what I wanted to show you first was what he did was he did his tunings. Oh, sorry about that. Yeah, that's right. He did his tunings with, it's in Texas, so it's going to be hot, cooling degree days and school days. One thing I wanted to show you first off was, you can see it's a really good fit. But But what happens if we drop the school days variable? You'll see that, yeah, this fit is still acceptable. And there's very few of them actually that were good without school days. I'm showing you a couple that are kind of really good with or without. But this is showing you one without and then with. So you can see that there's a real difference in using this variable. It really helps having this occupancy variable. And another one I have here is Gleason, I think it is. Yeah, Gleason. It's another one that's similar in that way. So it's a really nice fit, and without school days, a less good fit. Okay, but they're still good fits either way, but it's better with school days. But what I'd like to show you is, I want you to see, go back to Bing, and this is going to be the case on just about every meter. What I'm looking at here is a scenario inspection. So this is showing me what does the data look like, let me say it differently, these first 12 months here, so it's about to here, something like that, is my base year. Okay, so that's why baseline and actual are about the same. And then after this is the next year. So there really wasn't much change in energy usage. You can see that the usage has gone down a little bit, and that's probably COVID and summer combined. So this is, that's May and that's June. But the COVID started in March, so it started here. So it's the last 4 points. But I want you to see what would have happened if we just tuned this with cooling degree days. It was a good fit, okay, but we didn't use this school day variable. How is that going to affect? Well, you can see that. So the effect is pretty huge here. So what I wanted to impress on you, at least in my 7 minutes, is if you were using an occupancy variable, for example, with your school district, then it really helped you and might have taken care of any problems you would have run into. Okay, that isn't always the case, but it is often the case. So here you can see it's like, oh, there's all this new savings here. Well, no, there isn't. We had a lot less occupancy and therefore a lot less usage. Okay, so let me bring it back to the tuning we had, and we'll look at it again. And you'll see that, yeah, I mean, still we have a little bit of savings, which maybe isn't savings, but you'll see how much better it looks. Let me just show you that same idea for a couple meters here. So this is one where they tuned with the school days, and you can see the usage is, shoot, make this 24 bills, 13. Okay, so the first 12 months is my fit, and then after that is post-fit. And so the usage is about the same, but the last four bills is the COVID period. And the usage, yeah, maybe it's a little low here, but let's look at what option C would have looked like if we didn't use school days. And you'll see a huge difference. It's the same thing on meter after meter. So here it is. Again, this one's it's low. It is low, but what if we didn't use school days? What would it look like? And you'll see it's way low. Over and over and over, it's the same thing. I'll just do one more. So here again, a third school. So here, actually, my usage is a little high. The COVID period usage is just a little bit high. So this is my tuning period, and this is post. And if I got rid of the school days variable, it will be a lot more. Okay, so this is a district in Texas. What this means basically with this district in Texas is that these guys actually have been turning off their HVAC when there isn't school. They've been turning off HVAC and lights. They've been very good at it, and that's why these fits work with school days. I'm going to show you another project where it's a little bit muddier. That was this one. So this is it's not Rapid City. I changed everything so you wouldn't know, so no one knows who this is. But I wanted to show, let's see, this one. So Island City. Okay, so this is one where they tuned it and they didn't have school days, and you can't really use school days. It's just not going to work with it. Okay, I have a low T statistic, so I can't use school days. And so with that, if I looked at the scenario inspection, too many. Well, just look at the last. So this was the fit was somewhere in here, and then this is what's later. But you'll see that that this last year, at least the last 4 or so bills, actually, I see no difference at all, really. I see no difference. They were already saving a little bit, it looks like, so I don't see anything. Let's look at another one real quick. Greenwood E3. So this is another one where they didn't tune with school days. Make sure, see, and then again, it's muddy. I don't know what I see. So what I'm trying, I guess, to explain is it's not always so clear as that district in Texas. That one is special. It's like you look at each meter and you can see, wow, that using school days really helped to make these fits better, and you really can see the effect of COVID. And here, not so much. It's just really kind of muddy. I think I'll just show you one more. I guess I did show you. I showed you enough. So I think that's it from me. So we'll move on to the next comments. Hold on a second. Let me shift this to this. And how about Marco? You're up. So this is Marco's data.
So welcome everybody. My data will not have the advantage that John had with showing multiple years, but this first set is a K through 12 schools gas use, and we're looking at the adjusted baseline and the actual, especially around the, March, April, May 2020 when COVID kicked in. So we're looking at this data and it's like, well, is it really from COVID or not? So one of the things we learned is that we're now more dependent on remote access because they didn't let us back on the campus at that time, and some of the people that we would have liked to talk to were out for a week or two at home, so we couldn't talk to them. So we were depending on the BMS, and you can see in the lower slide where the indoor air temperature is moving up and down at a particular pattern, and then about the time when they told us they had switched to unoccupied mode and changed some of their parameters, that's where we marked it COVID. You could see that it actually changed profiles, and you can't see it, but it's that line that says the COVID switchover line is near the end of March. It's something like March 28th or something like that. And so if you look at the top graph near the end of near the end of March, you get an idea that this change is probably related to their change in control and lack of occupancy. So we did not have the occupancy variable in this particular account, but using the BMS helped us see that. So that's one of the things we've learned now, is that during this COVID, we are much more dependent on working virtual, so either phone calls, of course, Zoom meetings like everybody else, or using the BMS much more than we used to in the past to prove whether or not what we see in the utility bills is actually because of changes on site. So this one was kind of interesting. This is not a school, but you can see that the pattern of the blue line, which was the monthly data, was very erratic. So, we said, like, well, how do we know if it's actually trending down? So we use that 12-point moving sum average that's in metrics to start looking at data when it's erratic this way, to also give us an idea whether or not it's starting to trend down. So that's one of the techniques that we've started to use to look at this data, especially over a longer term. So as John was saying when he was showing the facility that was not in Texas, the one that was less obvious. So we're actually looking at kWh cost, electrical avoidance on the top graph and gas at the bottom. So when you start to see something like this, you don't necessarily know if two things. You don't necessarily know if that drop is actually for the because of COVID. So for example, we're looking at the bottom graph for around the February, March area. You don't have the benefit of the previous years, but there tended to be a drop anyway around March or so when the heating equipment started going off. So it's hard to tell. And then one of the items was, a discussion with a customer saying, it was actually near the June timeframe, and got a call and said, "Oh, we're about to switch over to unoccupied, force it into unoccupied mode in our buildings. There's no longer staff here either." But, and they were asking, we were talking about baseline adjustments and such. The thing to think about is that school in particular didn't have any summer occupied times. They didn't have Cub Scouts or any kind of church activities occupying the school during the summer. So during that summer, the school would have been occupied only. So even if there is a reason to discuss baseline adjustment, you have to think about the start and stop times, because even with COVID, there are times when the building would have operated in a manner similar to what it's running due to COVID anyway. And those times, those time periods would not deserve to have a baseline adjustment. The other thing we discovered is we have some facilities where we don't have a login to the utility web service or shadow bills. We're actually getting the utility data from the customer's accounts payable department. Well, some of those accounts payable departments are closed, and even though people are working from home, the paperwork sitting at the school. So we've gotten a number of delays because of the COVID. So just tracking utility data for us in some cases has been affected by the COVID. And then that second bullet's the one I already talked about, that there are time periods like summer unoccupied, where the school really is fully unoccupied, where its operation is going to be similar to how they're operating with COVID anyway. So those are three of the observations we had made during this time frame with COVID. I think that's my last slide.
Okay, Bill, you're up.
Thanks. Hey, thanks, John and Marco. And I also want to give a shout out. I saw a lot of coworkers and friends in attendance, so glad you could make it. What I'm going to do, the slides that I have, I just pulled together some, I'd say really just a sampling, and it's everywhere from part of the Southeast to west of the Mississippi, and different, I would say different municipalities, schools, things like that. So, and I apologize in advance. It's kind of hard to see some of these. There's a lot to get put on a slide. So I'm just going to summarize as I go through. But in this case, I looked at a municipal building, and I tried to pick some time frames a week and look at the building schedules, the HVAC schedules. And in this case, there was no change. Here's a recreational center for it's a municipality. And again, kind of looked through all the different schedules and found out that they really haven't changed, at least as far as the schedules go for the HVAC, the operation of the building. So here's a K through 12 school where we had some utility data, and we definitely noticed, you can tell starting in April, that they have definitely changed the operation of the building, resulting in a decrease in energy usage, which you would probably expect. But again, some of the other things I've looked at, some of the other buildings and facilities, not so much. So again, another set of schedules for a different set of K through 12 schools. And the only thing I saw, which is to me odd, is on Saturdays, they were occupied, and now they're not. So, but otherwise, all of I would say the Monday through Friday, which I would expect to be, days that you could leverage changing the schedules and the runtime of the equipment, is not happening. So here's some trend data, just looking at, this is a K through 12 school. Just looking at, I just thought I'd pick outdoor air and see what's happening there. So this is a plot of the outdoor air damper and the supply fan speed. And again, before COVID and then during COVID, really no change in operation. And then I did stumble across one. This is a K through 12 school. that it does appear that in April they more or less changed the schedules to unoccupied, shut down the HVAC, whereas in February they had more of a typical schedule, Monday through Friday, 7 a.m. to 4 p.m. So like Marco said, maybe some quick lessons learned I gained from this, and especially taking into account what John shared as well as what Marco shared, is probably to really get an understanding of this. One is talking with the customer, or a good feel of what's going on in the building, but probably a combination of having energy usage normalized, as well as some equipment trends and things that give you some insight into how the building's operated or how it's changed operation. And then also from the slides that I saw, to see an opportunity to talk with the customer, which can be or sales officer, whoever that you're working through and interfacing, which can be a double-edged sword, and we'll talk a little bit about that. But in most cases I saw, it appears that they're running the building normal, and I'm pretty sure that in a lot of those cases, the occupancy is either reduced or it's shut down. And then the other thing, we'll talk a little bit about this, but just consideration for future impacts on future projects. So a lot of there's the part we've talked about and looked at in terms of existing projects and how to handle the changes. Is it a baseline adjustment? Is it non-routine? But the other thing, there's a trend towards, in the future, running buildings, running the equipment more filtration, more outdoor air. And so I guess the takeaway I have from that, and starting in my case, talk with offices and customers, is I think that's all fine and good if it's not an energy performance contract, but if it's going to be an energy performance contract, there's a consideration there for how that may impact the financials of the project.
Right. Now, I mean, that might be a baseline modification, am I right? If they're now putting in more outside air or more scheduling or thicker filters.
Yep.
You agree, Marco?
Yeah, it would. One of the odd things is what if you come in to put in equipment that's going to, let's say you're not going to go to 100% outside air, and you put in UVC light and filtration, and you hope that the airflow will now be lower. So if you do a project like that, then you're still going to have to understand what they're installing, because there'll be parasitic loads. And like Phil said, let's say you go to MERV 13 and you increase your air pressure drop, then the flow is going to go down. Your energy is going to change. You're going to want to know what they're doing to collect all that information to make a baseline adjustment.
Yes.
Right.
Now, are we going to cover some of the? Oh, go ahead.
Well, yeah, one thing. Yeah, and correct me if I'm wrong, but my understanding is they put in thicker filters, let's say HEPA filters, where they didn't have them before. It doesn't always mean that they're going to use more energy, actually. In my understanding is if you have a constant volume system and you increase the pressure drop across the filters, it's going to back the fan motor down. There will be less flow, less air is getting to the zone, but the fan motor is going to use less energy. So by putting in HEPA filters, they might end up saving more energy. If it's a VAV system, that's a different story. Then you can end up using more. You guys want to tell me I'm wrong? Because I might be, but I don't think so.
Or to play devil's advocate, John, if they resheave the fan, then to keep the airflow the same, then it could. But I guess the point of all that, and this is good, is it depends, right? And back to what Marco said, I think it's key. Maybe what we've tried to demonstrate here is there's no one size fits all answer. You really have to understand the building operation and what's going to happen or what's proposed to be able to model it appropriately.
Yeah. So I think one thing I've noticed in webinars or presentations about M&B is people often will mix options A, B, and C, and D together. And one conversation will be applying a commenter might be talking about option A and someone else is talking about C, and that just becomes a big cluster. And so I think maybe what might be good is to just talk about A to start with. Do you think that there should be, or do you expect you're going to run into any baseline modifications in option A situations?
I mean, yeah. So if you had a constant speed motor and you put on a variable speed motor, variable speed drive onto that motor, and now you're going to change, the pressure drop or the airflow characteristics, then there could be a change. How significant it is, I don't know. It depends on the size of the motor. Like a forward curve fan is high velocity pressure, and you put in increased static pressure, it'll back off a lot like a variable speed drive. But so if it was a plug fan, then it's high DP fan. I would think that the characteristics are different. I can't tell you off the top of my head. The other thing I've been hearing lately, and I think it's even in some of the ASHRAE information, that those new ECM motors versus the permanent split capacitor motors react differently to the increasing the pressure drop. I don't know which way it goes, but these are some of the things we might have to brush up on to figure out how that's going to affect possible baseline adjustments. But I'll bet you a lot of people are just on option A, or might not even have it instrumented to track all that. So then it'll just be discussion with the customer about how significant the change might be, whether you're going to ignore it or you're going to put something in to measure it, or just do a theoretical engineering calc.
Agreed.
A lot of times option A, though, they only measure once. I mean, I know depending on who you're looking at, like the IPMVP wants you to measure every year, and I think FEMP does too, but in the past they didn't necessarily say that. If you only measure once, let's say just after the project, and then you just kind of copy the results every year in your M&V report, then there shouldn't be a baseline modification. Am I right? There's no reason to be.
No, then it's probably in your contract that the customer, it's the risk reward, right? How much do I want to pay for M&V versus how much do I believe the savings?
Right.
You put in a motor, I only want you to measure it once. I'm not paying you to come out every year. So in that case, you're just contractually set up that there just won't be a baseline adjustment unless the customer came back to you, and you might have an option to say, well, I'll do it for so much money or something like that.
That's what I was going to back up, Marco, is I think that's another consideration to all this is if baselines need to be adjusted, if models need to be rerun or energy recalculated, there's a cost to that, and who's going to pay for it, and is it value added, which I think is part of the conversation that has to be had.
Yeah.
Okay. But yeah, if you are taking measurements every year, then yeah, for HVAC applications, then there might be baseline modifications. How about for lighting? So you don't take lighting measurements every year, you just take them once. And the savings is going to be less because they left their lights off. But you just contractually have agreed, this is what the savings are. We measured it in year one, and we just assumed you're going to run it this many years. So there's no modification, no anything to do. Is that correct?
I suppose
I would say go ahead.
Go ahead, Marco.
Well, I mean, I was going to say, I would typically say yes, there's going to be no change because the ESCO is usually responsible for the demand, or I think IPMVP calls it performance versus operations. The ESCO will be responsible for the demand reduction of that ECM, but the burn hours, that's under the customer's controls, typically contracted to the customer as the agreed to number. And so you do that one time, you do that one time measurement pre-post, and then after that, the hours are their concern.
No, that's a good point. And one possibility would be you could come up with what what the savings would be based on adjusted hours for some period of time. But again, I would wonder, is there value in that? If it would almost ultimately have to be the customers, like there's enough value in that we're going to pay the ESCO to recalculate that and tell us what it is.
But okay, so this seems strange to me, because if you follow that thinking, then you can say, well, our school, we just shut it down and we told no one to show up, and all the lights are off and all the HVAC's off. We did option A, you measured everything once, and since everything's off, we want zero savings on the book, because our baseline is zero. We would have used nothing, and actual is zero, so you don't get any savings. In fact, we did it for all of our schools, and therefore you're not going to meet your guarantee. I don't think that. I'm just taking your argument just a little further, and I don't buy it. I don't buy it.
You want to go first, Phil? I don't mind.
I have a note, and Marco, you've already hit this, I think, and ultimately you go back to what does a contract say, and you try to have a discussion with the customer about what makes sense. And most contracts also cover, there's a force majeure clause typically, and so of course then that could be a conversation of does COVID-19 fall under that or not, but
right, because that's the problem, is if they just close the buildings down, no one goes to the buildings and there's no savings, and now your ESCO project's underwater, and it's not fair that you should be writing checks to the client. That's not right.
I agree. There's the contract, and then there's how you handle your relationships with client. So you can stand on the contract, but life is very rarely that straightforward.
That's right. That's unfortunately true. That's where I'm not very good. Okay, and I guess that whole concept of they close the buildings down, or no one's there, or the usage is very, very little, that applies in all options, A, B, C, and D, I guess. And so that one just cuts all the way across. Okay.
John,
because this could, go ahead.
I think my audio cut out for a little bit. So I just want to say that I look at it as 4 parts, and Phil, hit on 2 of them. So technical, financial, contractual, and relational. So you're always going to have that relational issue with the customer. You only when the relationship is a little tense do you have to fall back on the contract. But one of the things in the contract, and technically you always want to consider for these performance contracts, is some agreement around minimum load, minimum, maximum, whatever load that's going to be sort of like a baseline load that you're going to need to have to produce these savings, and agree that the customer abides by that. It's like doing a chiller retrofit, right? You do a chiller retrofit based on some baseline. So the baseline's not only energy use, but what was the load, over the year, and the load profile. You have to set some kind of minimum to get your savings. So it's your baseline or actual, whichever, in that case it's probably the higher, but you want to set some limit. Similarly with the lighting, I always laugh at that, because with lighting, is it the utility? Do you take the utility view? The more you burn, the more you earn. Like with rebates, you used to be able to get for how many hours you burnt, you got rebates, or you met your guarantee faster. So you have to convince the customer that there is some minimum inherent load, whether it's in the calculations or in the contract.
That's often not in the contract though, right? I don't think I've ever seen that in a contract.
We
assume you're going to burn this many, or your chiller load's going to be at least this, no matter what happens.
Your savings, even in a case like that.
Is it actually in contracts? I've never seen it.
Yeah, it'll be in some contracts, or it'll be referenced. You make references to the loads that are in the calculations.
There's that. Yeah, so they're baseline conditions. Those go in the contract. Yeah. But I haven't seen a contract saying we're assuming that you're going to use it at least this much. Yeah, baseline conditions. If you change it from this to this, then we'll write a baseline modification. That's one thing, but that's like if they're going to use more energy usually, or sometimes they're going to use less. They change a set point or they change a schedule. But what if they just quit using energy? That's a different story.
Yep.
But maybe we shouldn't get hung up on this. Are we done with option A? Can we move to option B?
I think so.
That's option B. So
Sure.
How is option B going to be different than A? I think you kind of covered B already, but let's talk about it anyway.
In my opinion, option B and C are maybe more similar, because if you're looking at energy, I can see it being it could be a good and a bad thing. If you're looking at energy, then and normalizing, it may be a little more straightforward to do a baseline adjustment, because typically that is written into the contract language and it's more commonplace. Whereas with an option A, you've got a key parameter and you're saying, hey, we're going to stipulate everything else. We're going to measure this. And to your point, John, earlier, one time we're good. Whereas I may be wrong, but it feels like option B and C, you're maybe set up to that's the nature of it, is to do baseline adjustments or handle things that way.
Mm-hmm. Yeah, because you're measuring every year. Right. It gets real sticky when the chiller load, as Marco was talking about, goes way down. Now
Yep.
what? And now what? That's like, where's my savings? And
maybe something similar with B is all key parameters. So along with option C, your model or what you're normalizing for should be based on the identified key independent variables. So if you have something that's outside of that, I think you would consider it a static factor, but you still have to account for it. But maybe COVID is technically a static factor.
yeah. Do you have anything to add to that, Marco?
No, not really. I agree with Phil on that.
Okay.
We should also cover at some point like new projects, because that's interesting.
We'll get to that in a minute.
But can I just say that, one of the good things about this COVID is the fact that, you can see that the unocc period tracking, or the occupied days, like you showed us at the very beginning, a lot of people may have worked, and just looked at weather, and that, they were solely focused on weather. And now we can see that other variables like this are very important. So that's been a good learning for us.
But unfortunately, that only works with schools or something where you have a big variation between months. If you're looking at an office building where they're, 95% occupied, 93, 92, 96, it's not going to really work with your regression, because then you're going to extrapolate when they're down to 20%. And extrapolation isn't so good, regressions. Okay. I don't feel that clear about option B and how this is going to affect things. And I still don't feel like we have a clear solution, but maybe there isn't one, on the fact that, yes, my chiller load is way down. Yes, they pretty much shut the building down. There's one or two people in there and we're only heating a couple rooms or whatever. Therefore, savings has gone away and it's not our fault. But like I guess you guys have said, it depends on the customer and the relationship, and I guess we just take it from there, right? That's kind of how it works. And is this something the M&B people don't handle, and it's something the higher ups deal with?
State that again about what I don't handle.
But the problem is that if there's less usage, then there's less savings to be had. And you assume there's a lot of usage. Well, now there's a lot less usage. Therefore, our savings is really small. Therefore, we're not meeting our contract. Therefore, an ESCO can lose a lot of money this way. And, so what do we do? And I don't think we really came up with anything that was even clear of an answer of how we proceed on that.
I would still go back to, you need some kind of minimum load or
Right.
operation under the customer's control, and that's their part of it, and the vendor has other aspects under their control that they're supposed to be responsible for, and
That
you
works.
sort of have to use that to make your argument that you should still be getting recognized some amount of savings.
That works.
If anything, I see it as a lessons learned. If you look at IPMVP guidelines or a compliant IPMVP plan, there's a lot in there, and I know myself and maybe a lot of people, day in, day out, projects go well, they make money, everybody's happy, and it's easy to get complacent until something like this happens. And then you bring up a good point, John, and we're talking about, well, it was assumed the chiller would run at this load most of the time, and now it's not. And so again, I feel like it just underscores a lot of the work that was done by some really smart people that say, look, you really need to have this in your contract or have this covered. And again, day in, day out, when everything's operating great and making money, nobody thinks about those things. But when this happens, it underscores the reason for all those details.
Okay, that's good. That was a great answer. That was a great answer. Okay, option C, is there anything to add for option C? We've already seen, using a variable. What if you didn't use a variable? You have a school district, and my assumption is you're just going to do some calculations and make some model based on what you know about the equipment that's been turned off, and I think that's the best you can do. What do you think about that?
I think short of having other independent variables that maybe help with correlation, like you showed, I also think being able to get into the equipment controls, things like that, and be able to actually trend and look at what the equipment's doing to get some insight above and so your assumptions may be, oh, okay, this is COVID related. They're not occupying the building like they were. But I think it's important that you really get into the details and make sure your assumptions are sound.
Yes, I agree. Marco, do you have anything on that?
Yeah, so the customer, you might not, the building might not be all the way closed, but the customer may have made some changes, and your utility use goes down, and then it looks like you have a lot of savings, and the customer comes to you and says, hey, you can't take all that total amount of savings. That's when it gets sort of difficult, because there's the engineering calculation method you might try, where you try to figure out with your energy engineer, what did they do and how did it affect the savings. Because with option C, it's not just the ECMs alone, it's everything outside the boundary of the ECM that gets measured. And so it's a lot more work to do the engineering method. You might have to think like the big data people and look at a year or 2 years before COVID and see the profile, and maybe average that profile and get the customer to agree to that your actual, the average of your actual use in the last 2 years is what your building would have used this year, or not necessarily on average, but the regression of your actual for the past 2 years, and use that as a possible replacement for the actual now that's a lot lower because they turned equipment off, and say
that's good.
Something like that.
That's good. I like that. Bill, any response to that?
Again, I think it's good advice and input, and there's just a lot of things to consider. So I'm kind of glad and I'm sure if we take questions or ask people that are attending, there's something that the three of us miss. So I guess
Absolutely.
The benefit of this is I think, hey, I've got these 2 or 3 things I've learned, or I can, but then you or Marco mentioned, I'm like, oh yeah, that's good as well.
That was a really good idea. That was a really good idea. Okay. So let's talk about new projects. I'm going to skip option D. I hope you don't mind, but there's so little of it out there. New projects. So it looks like there's going to be a lot of projects that are just starting because we've had this big hold. We haven't been doing IGAs for the last 6 months, and now all of a sudden they're going to start happening. And we've got this last 12 months, 6 of which are not so good, or 5 of which are not so good. What should we do about this? Why don't we start with you, Phil?
What I'm learning, this is dynamic again, kind of on the fly, but hopefully I'm answering the question. What I'm seeing, and maybe Trane is a little bit different than Honeywell or John, even what you're seeing, but I work with the sales offices a lot, and so what I'm seeing is that the sales offices see this as maybe an opportunity for future projects, again, to, hey, we need to go in and change the schedules and put in better filters and increase outdoor air and possibly increase CFM and do all these good things that the CDC, ASHRAE, a lot of smart folks have recommended. So I think the consideration I have that I'm trying to talk with energy engineers and the offices and everybody at that point is just understand it will likely have an impact on the financials of the project and the payback, and not necessarily bad for reasons both John and Marco mentioned. It doesn't always mean that the energy use is going to go up, but I just see it as the opportunity. I need to make sure that people understand that it's not the same as it was yesterday. And if everybody's talking like this is the new normal and moving forward, we are going to bring in more outside air. We are going to increase filtration. We're going to put UV. If all of that stuff is going to be the new normal, then I just think it's important everybody understands for an energy performance contract, you may forfeit some savings, which may impact your cash flow.
Marco?
So I agree with John, Phil, that, and I call it the left hand versus the right hand syndrome. A big organization, this pandemic has created opportunities to provide solutions and value to the customer, but that's like somebody working on the left hand, and as Phil said, unless you're coordinating with them and they realize that they're working on your performance contract, then things can get done that you have to scramble to catch up with. The other item that I sort of worry about is you can read studies about how people or mass groups of people have been forced to change their habits. Like, I think there was a taxi strike in London and no taxis were running, and for, I don't know, months, everybody had to figure out how to get to work without using the taxis. And then when the taxis came back online, they discovered they never got their ridership back up again, because there's some theories about people just lock in the habits. So what habits are we creating now that might continue on? So that's the part, like customer changing their behavior on a more permanent basis, the left-handed versus right-handed work by some organization. And then there's new, if you're chasing a new ESCO project, and there are some regulatory agencies that recommend that you use the most recent 12 months, right before you do your IGA. The only problem with that might include months with COVID and low energy use. So, on one hand, the customer might say, great, you're being forced to have to really work hard to get savings because your baseline is really low. From an ESCO standpoint, it's an unrealistic, once in 100-year or whatever it is, lifetime event, and that should not be the baseline. So you're going to have some discussions with customers around what time period to pick for a baseline.
Yeah, if they insist on the COVID data, you might choose to wait. Wait 6 to 12 months.
Yeah, it's kind of hard to do if you have to keep issuing paychecks.
That's right. That's what they've been doing that anyway for the last 5 or 6 months. Okay, so we have 4 minutes to go, and I thought we'd have a lot of questions, and I don't see a lot of questions. So do you have any last comments? I don't. So Phil, we'll start with you. Do you have any last comments?
I was going to say, I looked briefly at the questions, everything, and I'm glad Shankar is here, and he weighed in on a couple, which I appreciate from an IPMV perspective, and it's good input. So thank you.
Okay. Marco.
Well, I've said before, never waste a good catastrophe. So
Yeah.
I know it's sort of probably too early to think like that or say something like that, but really, just an opportunity to see how your buildings react in unoccupied mode during, other time frames other than just the summer. If it's a K through 12 schools, it's a good way to learn how to be better at working remotely, talking to each custodian in each facility or the cleaning crew at an office building, to get better about that. And I've discovered that a lot of the large corporations have been talking about how they during this time frame have used a lot more remote access. So this is a good time to look at what you can do to increase your performance in remote access, and then improve your virtual presentation skills. Like I don't do webinars like this, but part of this COVID is like to start practicing to do things remotely. So there are some opportunities, growth opportunities in this sad situation that we can use to improve ourselves.
Good. I think that's it. If you have any questions, you can email us. And I didn't give the email addresses of Marco and Phil, but if you have questions for them, you can just ask us and we can forward them to them. Okay, Marco, Phil, thanks so much for joining us. This was a really good talk and I really enjoyed it. It was good. Thank you.
Thank you.
It was a pleasure. Thank you.
All right. Goodbye, everyone. Thanks a lot.